All right, so a little comment on y absolute value of x. So you may have noticed, I mean, we don't focus a lot on this in learning what the derivative of ln of x is. For example, derivative of ln of x is 1 over x, right? So that's basic. Technically, we only consider the absolute values of x. We can't have a negative x. And if you see in green over here, so I'll just have everything on the screen. In green, I have the function ln of x, okay? Now, ln of x is a logarithm equation or graph here, and it only exists when x is greater than 0. So you cannot take the logarithm of a negative number. Remember, because the logarithm is really an exponent. So, for example, natural logarithm e to the power of what will give you a negative number. There is no value for x that will give you a negative number, or no power that will give you a negative x. So that means that negative x is not possible. E to a large number can give you a large value. E to a small number can give you a small value. But e to no value possible will give you a negative value, right? So we only consider x greater than 0 for the logarithmic function. So that means that when we take the derivative, okay, now look at this, the derivative of the green graph is the blue graph here, okay? So the derivative of, how am I going to do this? So when you take the derivative of ln of x, okay, it's 1 over x. And so these are the plots of the derivative points right here. And so it looks like 1 over x. But the graph of y equals 1 over x itself has 2 arms to it, right? Because if you consider negative values, negative, like 1 over negative 1 is negative 1 down here, and so on. So the 1 over x graph is both arms of this blue graph. One is dotted here. I've got one as dotted. Now, it has to be absolute value, technically, because the logarithmic graph is not defined in the negative region here, right? That's why it's absolute value. So again, because the green graph does not exist where x is less than 0, the derivative can't exist there either. That make sense? Hopefully that does. Now, what does that mean for application? Well, again, the derivative of ln is 1 over x, but really we only consider the derivative of the absolute value of x. And you'll see that in your textbooks, and if you ever wonder why the absolute value signs there, that doesn't change what the derivative is. No, it doesn't, but it does affect the domain. And because the logarithm graph it only exists where x is greater than 0, that means that the derivative also only exists where x is greater than 0. Okay? So the derivative of ln of x is actually 1 over the absolute value of x, because the natural logarithm is not defined where x is negative. Okay, so that's a little comment on that. We have a domain here, x greater than 0. And x can't equal 0 either, right? Because like e to what power gives you 0? Nothing. E to 0 gives you 1, right? E to a negative gives you a small number, but nothing, e to no power will give you actually a negative value or will give you 0, if that makes sense. Okay, any questions about that? All right.